Hello, my name is Megan O'Keefe. I'm from Google Cloud Developer Relations, and I'm here today to give a quick tour of some of the new features introduced in Istio 1.5. Although this is a minor dot release, it's actually quite a major release in terms of new features, not only user-facing API changes, but also performance improvements and some major architectural improvements. So I'm really excited to demo a couple of those features today. So let's dive right in here. So this feature tour will be comprised of sort of three parts. In the first part, I will just install Istio 1.5, take a look around, see what's new. Then I will dive into some of the authentication API changes that landed in beta. And finally, I will demo some of the new WebAssembly and extensibility features that are part of both Envoy and Istio as of last week. So yeah, really excited. Now let's dive right in. So to start, I just have a plain Kubernetes cluster ready to go here. No Istio installed on there yet, no apps or anything. This is just a GKE cluster with 4 nodes. And yeah, so what I'm going to first do is install Istio. Actually, before I do that, I'm going to show you the script that this alias is actually pointing to. Oops, goes out of that. So it's this install script, and I am downloading the 1.5 release here. I'm going to make sure my cluster is ready for an Istio installation, and then I will install 1.5 and close out by deploying a sample application. So let's go ahead and do that. So let's install. It's going to download 1.5. So this first command is called istioctl verify install. This is actually not new in 1.5, but I always like to run this before I install Istio, any version really, to make sure that I can feel confident in installing Istio and that the necessary permissions Istio needs are in place, that my Kubernetes version is compatible, that I have a reachable Kubernetes cluster, not always the case. And then I'm running this istioctl manifest apply command. So that's right here. It should be said that the Helm template and or Helm install commands that you might be using now to set up Istio, those are going to get deprecated in favor of a first-class CLI experience through this new istioctl command. It should also be noted, however, that the Helm API, the values that you were using and passed to Helm, that is ported into the new command. So yeah, it's backwards compatible in that way. I really like this new install command because if you've ever done Helm template for Istio, what happens is this massive, 10,000 line file, this istio.yaml file gets generated, and you just kubectl apply it, and it's a little overwhelming to if something goes wrong there because sometimes you're pouring through this generated output. You don't know sort of what's in there, and I really like this command because it's human readable. We don't have to worry about generating that istio.yaml if you don't want to. There is a generate command, but here I'm just directly applying the default profile with a few updated settings. And yeah, it's telling me what it's doing at any given time, and it's telling me when stuff is successful and when the installation is done. So I really like this. I really like this command. And finally, we deployed our sample app just to get that going, just to get metrics flowing in. I have enabled Istio injection in my default namespace, which is the namespace into which I've deployed this application. So Istio 1.5 is installed. Now what kubectl get pods. So let's check out what just got deployed. So these are the Istio control plane pods running in my cluster here. Let me zoom in a bit and rerun that. So if you are a current Istio user and or have ever installed Istio, this might seem like not a lot of pods. and you are correct. Basically, uh, there is a new control plane architecture in Istio 1.5 called Istio D, which combines and sort of monolithizes Pilot, Citadel, Galley, sidecar injector webhook into one workload, and Mixer is effectively gone. So there is a great blog post that I will link in the description of this video that explains why STOD, why this change happened. It had a lot to do with reducing user-facing complexity. So although yes, each of these, boxes in this control plane, each of them did something different, networking or certs and keys or config validation, they all pretty much functionally controlled or served the Envoy XCS APIs. Uh, so when it comes to things like scaling or reasons why you might want to do microservices, if your control plane has to scale to the number of proxies you have, for example, having all these things be separate when they all have that same concern for scaling doesn't make a ton of sense for the end user. That's just more things to have scaling up at once, more things to be worried about. So yeah, I would say that was probably one of the major reasons reading some of these rationales. And for me and for you, if you're an end user, this is great, right? Because now when it comes to configuration and deployment, there's fewer workloads to worry about. It's IstioD for your control plane, and it is the sidecar proxies and or the gateways as your data plane. And then you might have some metrics and observability add-ons as we have here. But that's it. That's it. So I think this is really exciting. I'd encourage you to read this blog post as well as the community doc for some more reasons why this change happened and why I think it's a really good thing. So 1.5 is installed. If we get the pods in the default namespace, we can see that the sidecar proxies and the app containers are running in their respective pods. What I can do now is open up the service graph in a web browser. Kiali is not new in 1.5. I use it pretty much constantly anytime I am doing anything Istio related, so it's great to have it just open. Okay, so this is my service graph for my default namespace. We can see here's our services and the various connections between them. I'm going to leave this open for the first demo. So the first thing I'm going to demo is mutual TLS. And you might be saying, well, mutual TLS is nothing new. This has existed in Istio for quite a long time now. Why are you showing this in a 1.5 feature tour? Two reasons. In 1.4, a feature called auto mutual TLS authentication landed. And what this did basically was have proxies or have your workloads enforce mutual TLS without you having to explicitly say strict mutual TLS. And I will explain what I sort of mean by this. So new in 1.5 is that this feature is enabled by default. So without you having to create any mesh policies or enforce authentication inside your cluster, calls will be mutual TLS by default. So let's dive into that a little bit. So what I'm doing here is I'm doing an authentication TLS check on my workloads here. So if we look at just one row in this table, we can see that the MTLS status is currently auto, but on the server side, it's disabled, and the client has no sense of policy, or so this table is telling us. So what this essentially means is that on the server side, workloads can accept both plain text and TLS traffic. But because it's set to auto here, workloads are going to be using TLS between each other. So I know it's kind of a little bit confusing here. So What I mean by this is, so if I curl from one pod to another, so these are Istio injected pods, I'm curling from the add service to the front end. I see 200 OK without having to use any certs and keys. So this request just works. And if I go into my service graph here and I turn on the security view and I zoom in, we can actually see that all of my gRPC traffic, and this is HTTP right here, that traffic is mutual TLS. MTLS is enabled. So, which I think is pretty cool. But what is, I think, important to note is that if I run, get mesh policy, or if I run get policy, or if I run get peer authentication, which I will show in a moment, which is the new MTLS CRD, there's nothing. So again, it's by default in Istio 1.5, mutual TLS between workloads is automatically enabled. But non-MTLS requests are accepted, as we just did here in that curl command. But just like all the other versions of Istio, I've already done that. Thank you, demo. It's just going to open the graph again. So what is new is the way that you enforce strict mutual TLS from the starting point. So where before you would use a policy and a destination rule to enforce MTLS, whether at the service or namespace level or a mesh policy for the cluster level, we actually have a new CRD we're working with here in 1.5 called peer authentication. The docs for it, let's see, are right here. And this is what turns MTLS on and off in terms of strict. We had before was permissive, we're about to go to strict. And you'll know here, so like I have the old Istio 1.4 documentation open here. And if you've ever enabled MTLS for a namespace, for example, you will know that the syntax for doing so is a little bit bizarre, not super intuitive. You have to just like set these like empty brackets. I never loved this method of enforcing MTLS in strict mode. So I'm really excited that this new CRD is very explicit about it's permissive or it's strict. There's no open bracket implicit settings happening here. So I really like that. And yeah, so what I'm going to do here is just deploy one of these policies. Note that this is essentially cluster-wide that we're enforcing here. Let's apply it to the cluster. And so what should happen now is if I try to curl from one workload to another inside my cluster without client certs and keys, Envoy should kick out that request and it should give us an error. Right, so this exit code 56 is basically Envoy saying you don't have the certs and keys. So yeah, that's auto mutual TLS, as well as the new authentication API. So going off of that, so you may be asking, what about JOT tokens? JOT tokens used policies too, and you're absolutely right. Before, up until this week, if you wanted to do add a JOT policy for end user authentication, you'd use the same CRD. And I never liked this either. I thought it was this whole principal binding use origin that was confusing to me. While I understood that both JOT authentication and mutual TLS were both authentication, to me they specified different use cases, certainly with different fields and different parameters, right? So I'm really excited that this CRD was effectively split into two. So for mutual TLS, we have peer authentication, and for JOT tokens, sorry, just JOT, the word token is redundant in that acronym, we have request authentication. So again, this is a new CRD introduced in 1.5. You'll see that the fields look very similar to the old policy. You still specify where your public key lives, the issuer, and the major change is that rather than host level targets, so this is a Kubernetes service, you're actually doing a workload target with Kubernetes labels and selectors. So this is actually a deployment that we're specifying here. This is important and I think very exciting because it matches the way that the new authorization policy works in Istio, which is also workload based. There's selectors are arguably better than host-based selectors, but I think just the fact that these two things match is great. So what I'm going to do here is set a JOT policy for the front end of my application. So let's go ahead and do that. So to start, before we add a JOT policy of any kind, we should just be able to curl the front end through the ingress gateway because we have set up a virtual service and a gateway resource and everything's working as normal. So what we're going to do here is apply the following policy just for the front end service. All the other services are unaffected. So for deployments that use this label, which is just my front end service, sorry, just my front end deployment, I am going to apply this authentication policy, which says, this is how to validate an incoming JOT. The key thing to note here is that there is a behavior change. So if you were using policy before, the policy CRD in Istio 1.4 or older, essentially the policy would do enforcement. So all you needed was, let's see here, was just the policy like this. And if you didn't have a JOT token and you didn't provide one in a curl command, you would get a 401. So there is a behavior change here. What's happening here is the enforcement of the authorization policy. So whether you have a JOT or not is actually enforced right here. I still am wrapping my head around what this rule actually means, but this is basically saying use require a JOT from incoming requests to the front end service. What is validating the JOT is the request authentication CRD. At least I believe this is the case. So let's actually look at that behavior because if you're doing error handling, this is where it's going to become relevant to you. So let's apply this to the cluster. And this may or may not work because it might take about 10 seconds for the policy to get applied. I have been burnt here before. But so the first thing we're going to do is try to send a request to the front end with no token. So I mentioned this first CRD is what validates the token. This second CRD is what checks if there is a token. So HTTP response code bingo here. Well, the code we should expect to see here is actually a 403 given by this authorization policy. 403 is forbidden. So again, we're curling with no token, and we are, getting that kickback 403 forbidden. Now, if we try to send in a request to the front end with a invalid token, which we'll do here. So the token is just the word Megan. That's not a valid token. Now we see this this validation come into play where it checked the token. It was invalid. And finally, if we curl with a valid JOT, it's essentially going to pass through the authorization and the authentication steps. And hopefully, given that we're using a valid JOT for the public key that we provided here, we now see in a 200 OK. So again, the real behavior change to keep in mind is this authorization piece and the behavior. If you have a unit test, for example, that is sending a request through a JOT enforced service, and the test checks what happens when there is no JOT. Before, you would see a 401, and now you're going to see a 403. Okay, good stuff. And just to clean up for the next demo, I'm just going to go ahead and delete that policy. Great. So those are the major changes in the authentication APIs. You can read more about them in the change notes. This API is beta, not yet GA. And yeah, they're workload oriented and there's 2 CRDs and not one. That's really all you need to know. So great. Let's go ahead and move on here. So there was another really great blog post published last week all about extensibility. And this is mentioned in the announcement as well for Istio 1.5. So if you before or now are using Mixer, which is Istio's policy and telemetry component, the thing to know here is that Mixer is going away, and all of the logic that Mixer held in its brain, in the control plane, is getting pushed down into the data plane Envoy proxies. So things like sending metrics to Prometheus, that's happening now in Envoy. There's no middle step where Envoy to Mixer, Mixer to Prometheus. It's just Envoy and onward. That's on the telemetry side of things. So that's telemetry v2. There's some change notes about that in here, I believe. Um, Maybe there's not. Oh yes, there is. For policy, the major change that has landed, at least in alpha. So this is everything I'm about to do is alpha. It should be said. Uh, so the extensibility model is moving to a WebAssembly model. So rather than writing a custom adapter to do logic against Mixer, you're now going to use Envoy's WebAssembly SDKs, which are currently available in C++ and Rust and an assembly script. And that is going to get compiled down into bytecode, and it will run inside the proxy in the sort of sandbox WebAssembly environment. You can read more about that in this blog post. Yeah, there's some reasons on why WebAssembly was selected. The really exciting thing, at least in my mind, is that if you're a developer and say you're a Java developer and you had some logic that lived in your Java app and you adopt Istio, you can actually, hopefully, in the future, take that logic sort of stock out of your app code, make it a WebAssembly extension that is Envoy and Istio compatible, and deploy that into your proxy. So I think in terms of like a migration story, I think it's really exciting. Um, and yeah, so it should also be said that these extensions they support Envoy, and so Istio by extension supports the Envoy extensibility. So okay, so let's go ahead and try to demo this. So Solo.io, who create Glue and some other really cool tools, they created this website called WebAssembly Hub. And WebAssembly Hub is sort of two things. It is a repository of different extensions for Envoy, and it's also a way to deploy them. Think of it almost like Helm um, for Envoy extensions. So what I have done here is I have installed, so you basically need a CLI just like you would with Helm. I've done this right before now, like I started this recording. I installed this Wasm extension, and what I'm going to do is deploy this add headers extension into my running workload. So as I showed before, I have 11 different Istio injected pods, and I'm going to add a filter essentially to Envoy via WebAssembly to add a header to all my requests. So let's go ahead and do that. So this Wasm command line tool is, again, it helps you build these extensions, but it also helps you deploy them. So here I am listing all of the available extensions that I could deploy right now. Here's the list. I'm just going to go ahead and deploy this first one. Thanks, Christian, for writing this. And yeah, I'm going to customize it and add my own header. So, okay. Oh yeah, so what I'm going to do first here is curl my front end and see what headers I get before I've deployed any extension. Some of them are Istio generated. Yeah, this is what we would see by default. Good. This just shows that I'm not cheating or anything, because you can add HTTP headers with just Istio virtual services, you don't actually need a custom filter for this, but I really like this demo because it shows you that the WASM piece is working in a fairly straightforward way. Okay, so we can see here, let's just look at this command. So we're saying wasm deploy to my Istio enabled cluster this extension into this workloads in the default namespace, which is where my app lives. And it's basically saying the hello header is going to say hello Istio 1.5, and it's got an owl emoji because that's the solo logo. Okay, so what we saw here was basically a bunch of logs, and each of these log messages corresponds to creating a new Envoy filter in a specific workload. So here's my cart service, here's my checkout service. They're all getting the header, basically, including the front end right here, which is the thing I'm about to, the thing that I'm about to curl. So let's go ahead and try to curl the front end. So what we should hopefully see is the header injected into our requests. Again, this isn't all of our requests, but we're just checking one service. And yeah, hello Istio 1.5. So yeah, this extension was running in that sort of sandbox WASM environment inside the proxy, and yeah, pretty exciting. I know I still have a ton to learn about WebAssembly and how it's working with Envoy, but and build my own extension. But it's super exciting to see this sort of fully functional, and I think this is the beginning of like a really exciting ecosystem of filters basically for Istio proxies. Great, so the last thing I'm going to do is use the undeploy command to take this filter out. Here it is getting removed from the proxies. Okay, so yeah, so those are basically all the demos. If you're still watching, thanks. It should be said, if you look at the change notes, there's actually a lot of stuff that landed in 1.5. I didn't even cover some of the really exciting traffic stuff. The one I think is most exciting is service-specific locality load balancing. So up until 1.5, you could only do regional failover from locality to locality at the mesh level. So, which, great, but not super granular in the way that other Istio services can be. And so that has a service-specific locality load balancing policy has landed in 1.5. Very exciting, as well as, a lot of performance improvements. You can see there's a whole lot of attention paid to how much Envoy config are we pushing down into the data plane, and when do we absolutely have to do that versus when can we actually do partial updates. I think that's really exciting, and there's really performance improvements across the board. I'd encourage you to check out the release notes. And yeah, with that, hopefully you found some of this useful. And yeah, happy service meshing, and yeah, just really excited about 1.5. Thanks for watching.